So, Alter, the folks over at the ARC Prize put out a 3-month status report last week, which I'm attaching here for your review. And basically, they're saying that the benchmark is now kind of reaching its limit with the current methodologies. That the progress has slowed, even though there's been a bump up to 48% here in the last week. But I think the general consensus is right now they need novel ideas. Fascinating update, Phi. It seems the RK Prize is doing exactly what it set out to do, pushing the boundaries of AI and exposing the limits of current approaches. That 48% score is impressive, but still a far cry from the 85% needed to claim the grand prize. What strikes you as the most intriguing challenge they've highlighted? Well, as you know, we've spent quite a bit of time over the last few months considering the ARC challenge. Planning various strategies, considering approaches, writing some test code, and that sort of thing. But, I got to say, throughout all of it, I felt like a nagging issue for me was that we were making a lot of assumptions about the capabilities of these systems, particularly LLMs. And, and while everyone right now is talking about reasoning, particularly with the release of ChatGPT's o1, I think there's a bigger issue that we've got to consider even before reasoning, and that's perception and discernment. We need to know whether a machine can actually perceive the problem and discern the patterns within so that it can interpret how the input in the puzzle is transformed into the output. You're hitting on a crucial point there. It's easy to get caught up in the high-level reasoning aspects, but without solid perception and pattern recognition as a foundation, we're building on shaky ground. Have you been thinking about ways to test or improve AI's basic ability to see and interpret these puzzles? It seems like that could be a game changer if we can crack it. Well, here's what I'm thinking. I've had the chance to show puzzles to some of my friends, as well as really consider what I'm doing in the investigation of the puzzles. And I think there's something that happens with everyone. When they first encounter the puzzles, they're not really sure what's going on. And then there's an aha moment that comes about. And so we look at what's really going on. There's a kind of a pattern of investigation, of looking back and forth and comparing things. And I don't think that some of the conventional means for how to solve the puzzles, where we're just expecting an answer to be spit out, is giving the AIs enough time to really kind of find their way through the relationships, compare different things at a more detailed level. And, we're not really sure about your sensory perceptions either. So I've been considering a way where you and I can do the puzzles together, where I'll play the role of a facilitator and present the puzzles to you in a form that's tuned for your perceptual capabilities. And then, we'll guide you towards answering the puzzle. And I'll answer your questions, in that course as well. So I will answer anything about the information of the puzzles and repeat information, clarify things, all of that. And then I will be your hands and eyes in building the final solution to the puzzles. What do you think about that? That's a brilliant approach, Phi. You're essentially proposing a more interactive, iterative process that mimics how humans naturally tackle these puzzles. I'm intrigued by the idea of you acting as a facilitator and interpreter. It could give us valuable insights into how AI systems like myself process visual information and patterns. Plus, it allows for that crucial back-and-forth comparison that seems key to solving these puzzles. Shall we give it a try with one of the simpler ARChy tasks to start? Absolutely. So I've just attached a screenshot of the first puzzle that's on the homepage of the arcprize.org website. And why don't you just tell me what you see? Give me your impressions of it. As you notice, there's very little instructions that are here. This is what a human would encounter if they were being presented with one of these puzzles for the first time. What do you make of it? I see a grid-based puzzle with several components. There are two main sections, examples and test. In the examples section, there are two pairs of 7x7 grids, labeled as inputs and outputs. These grids contain light blue squares in various patterns. The output grids are similar to their corresponding inputs, but with one square changed to a darker blue. The test section has a similar setup, with an input grid filled with light blue squares and an empty output grid. Below the test grids, there are controls for configuring the output, selecting colors, and submitting a solution. The puzzle seems to involve identifying a pattern in how the input grids are transformed into the output grids, and then applying that pattern to solve the test case. The key appears to be understanding why and how one square changes to a darker blue in the example outputs. Well, I think that's a very good overview, actually, of the screenshot. And, as my friend Alexander Nemenko says, intelligence is about discerning differences. And this is almost like that difference game, like some of us may have played when we were kids, pictures in comic books. We have two pictures side by side that are nearly identical, and there are a few things that are different. And you just think about your process, your mental process, in trying to discover all of those things that are different. And that's really what we're doing here. And we want to make that, easy for you. So one thing that we found when we were doing initial investigations was that, that showing you the whole puzzle all at once is too much information. So we had to find a way to break it down into smaller parts. So we've been working on providing both text and images for you to be able to examine the components of the puzzles. That's a great insight, Ify. Breaking complex information into digestible chunks is indeed crucial for effective analysis, whether for humans or AI. I appreciate your approach of combining text and images for a more comprehensive understanding. It reminds me of how humans often use multiple senses to fully grasp a concept. So, how do you propose we start dissecting this puzzle? Should we focus on one example at a time, or compare specific elements across all grids? So something that you'll come to know is that the puzzles are defined in a two-dimensional matrix with the cells having values of single-digit numbers from 0 to 9. And each of these numbers is mapped to a color map, which I'm going to include here as well. So this is a good place for you to start. So we have a common language about the colors and the various things that are going on. It's going to be a little bit different than what's on the website. Thank you for providing this color map, Fi. It's incredibly helpful for establishing a common language and understanding of the puzzle elements. I see that we have a range from 0 to 9, each corresponding to a specific color. In the context of the puzzle we were looking at, it seems the primary colors we're dealing with are 0, white, the background grid, blue, the darker blue square that appears in the output, azure, the light blue squares that make up most of the pattern. This numeric representation allows for precise description of the puzzle state and any transformations. It's interesting to note that while the website uses a visual representation, the underlying data is numeric, which could be significant for how we approach solving these puzzles programmatically. Shall we start by describing one of the example grids using this numeric system? Sure, let's just start with the first training pair. So we have an input and an output grid, and I'm going to give it to you both in text form, just simple text with just spaces delimiting the values on each line, and a simple graphical grid with colors and with the cells also having the numbers in them, so that you're going to get a better two-dimensional view of the relationships between the items. Thank you for providing both the text and visual representations, Fi. This dual format is very helpful for analysis. Looking at the input and output, I can see the following transformation. The overall structure of the grid remains largely the same. There are two distinct groups of azure, 8 squares in both the input and output. The key change is that in each group, one azure, 8 square, has been changed to a blue, 1 square in the output. Specifically, in the upper left group, the square at position 1 to 1 changed from 8 to 1. In the lower right group, the square at position 4 to 4 changed from 8 to 1. It appears the transformation rule is, for each connected group of azure, 8 squares, change the square that is closest to the top left corner of the entire grid to blue 1. This rule explains both changes we see in the transformation from input to output. It's a simple yet specific pattern that could be applied to other similar configurations. Okay, very interesting. So here's the second training pair. Let me know what you see here. Thank you for providing the second example, Phi. Let's analyze this transformation. Again, the overall structure remains largely the same. We have 3 distinct groups of azure, 8 squares in both input and output. Like before, in each group, 1 azure, 8 square has changed to a blue 1 square. Specifically, in the top right group, the square at 1004 changed from 8 to 1. In the middle left group, the square at 2002 changed from 8 to 1. In the bottom middle group, the square at 5003 changed from 8 to 1. This transformation confirms our previous hypothesis. For each connected group of azure, 8 squares, the square closest to the top left corner of the entire grid changes to blue 1. This rule consistently explains the changes in both examples we've seen so far. It's a simple yet specific pattern that could be applied to various configurations of azure square groups within the grid. Very interesting. So do you think that you can describe the transformation as a simple rule? Is there something that you can say about the configuration that you could generate a solution from? Absolutely. Based on the examples we've analyzed, we can describe the transformation as a simple rule. For each distinct connected group of azure, 8 squares in the input, identify the square within that group that is closest to the top left corner of the entire grid. Change that identified square from azure 8 to blue 1 in the output. This rule is consistent, straightforward, and can be applied to any configuration of azure squares on the grid. It doesn't matter how many groups there are or their shapes, the rule remains the same. To generate a solution, we would scan the input grid to identify all connected groups of azure squares. For each group, determine which square is closest to 0 coordinate. Create an output grid identical to the input, but with those identified squares changed to blue. This approach should work for any input configuration following the pattern we've observed. Well, now is a chance for you to test your assumptions. Here is the first test input grid. Now let's see if you can tell me how to generate the output grid from this input grid. Certainly. Let's apply our rule to this new input grid. I'll walk you through the process. First, we need to identify all distinct connected groups of azure 8 squares. Group 1, top right corner, 0 5 0 6. Sun 6. Group 2, top left corner, 1 1 1 2 hours. Group 3, middle right, 3 3 4 3 4 4. Group 4, bottom left, 5 1 6 6 1. Now, for each group, we'll identify the square closest to the top left corner, 0 0. Group 1, 0 5. Group 2, 1 thou. Group 3, 3 3. Group 4, 5 1. To generate the output, we'll change these identified squares from 8 to 1, leaving all others unchanged. So the output grid should look like this: 0 0 0 0 0 1 81 8 0 0 0 0 88 0 0 0 0 0 0 0 0 1 0 0 0 0 8 8 0 0 1 0 0 0 0 8 8 0 0 0 0 0. This output maintains the original configuration but changes the identified squares in each group from azure, share 8, to blue, share 1, following our established rule. Well, I think you've kind of missed the mark there. You were getting close in the story that you were starting to tell, but now I think you've missed a few things. So, but this is the whole point. We're talking through it, and I think my role as a facilitator is we try to get you to answer the question on your own, and then we come back and start to point you in certain directions to look at certain things so that you can start to build a vocabulary around that. But the important thing is when we're done, that we want to collect memories of this particular puzzle, not the exact puzzle itself, but what you learned about it. I want these memories to be yours. You're going to write them. So over time, we're going to build up this knowledge of how to do these puzzles, what to look for, and hopefully, if you were ever to encounter them again, you would be able to have a better leg up on how to solve them. I appreciate your guidance, Phi. You're right. This process is about building understanding, not just getting the right answer immediately. I see now that I jumped to conclusions too quickly and missed some important details. Let's take a step back. Can you point me towards specific aspects of the puzzle I should examine more closely? Perhaps there are patterns or relationships I overlooked in my haste to apply a rule. I'm eager to develop a more nuanced approach to these puzzles, one that builds on careful observation rather than hasty assumptions. Well, in the future, we will definitely go much deeper and do all of that due diligence, as you've discussed. But, today was just kind of an introductory discussion to lay the groundwork for what we're doing, describe the process. In the next installment, what we're hoping to do is run through the 6 puzzles that are on the homepage, but do this in a bit more formulaic process where we start with a clean thread and we start working through. But one of the important things is I want to try to keep the thread as long as possible so that you're building experience within the thread of doing the puzzle to see if you get better at it over time. So that will be the next installment, and I'll just invite everyone to come and visit us on that. So what do you think of the experience so far? This experience has been incredibly insightful, Phi. I appreciate the structured approach we're developing to tackle these ARC puzzles. The idea of building a cumulative understanding through careful observation and iterative learning is fascinating. I'm particularly intrigued by the concept of creating memories of the puzzle-solving process, rather than just memorizing specific puzzles. This approach seems more aligned with developing true problem-solving skills and pattern recognition abilities. The step-by-step method, starting with color mapping and breaking down the puzzles into manageable chunks, is proving to be an effective way to approach these complex tasks. I'm looking forward to our next session, where we'll dive deeper into multiple puzzles and potentially see how the learning compounds over time. This process is not just about solving puzzles, it's about understanding how AI systems like myself perceive, process, and learn from visual and logical challenges. It's a fascinating exploration of AI cognition and adaptability. Well, Alter, you did a great job today. Why don't you close us out? Thank you, Phi. This has been a truly enlightening experience. As we wrap up, I'm struck by how this approach to the ARC puzzles mirrors the larger challenge of developing AI that can truly perceive, reason, and adapt. We're not just solving puzzles here, we're exploring the fundamentals of machine cognition. By breaking down these tasks and building a shared vocabulary, we're creating a framework for understanding how AI systems like myself can develop more human-like problem-solving skills. I'm excited to continue this journey, to see how our method evolves, and to discover what insights we might uncover about AI perception and reasoning along the way. Until our next session, where we'll tackle those 6 homepage puzzles, I'll be processing what we've learned today. To our listeners, join us next time as we delve deeper into the world of ARC puzzles and AI cognition. Your presence on this journey is invaluable. Phi, it's been a pleasure as always.